Hi, welcome to our video. My name is Muhammad Hazri bin Abu Sama with my friend Muhammad Nazran bin Adnan and Muhammad Adi bin Nasir. In this video, we're gonna learn a different approach to the smart home system based on IoT. The main article that we use is Design of a Home Automation System using Arduino. The second article is Smart Home Automation System using Bluetooth technology. And the last one, the third article, is a smart home system based on sensor technology. Right. So for our main article, the title is Android-less Automation and Security System for Smart Homes, which is the author Shafana and Ari Rashad, which is published on December 2018. In today's words, smart home systems have become increasingly important for convenience, efficiency, and security. However, traditional wired systems are often costly and complex to install, lack flexibility when it comes to upgrades or modification. As technology continues to evolve, there is a growing need for affordable and flexible home automation solutions that provide both security and control for modern households. The development of Wi-Fi and Bluetooth technologies now make it possible to design a low-cost wireless automation system that are easy to set up and manage. So for the objectives, the main goal of this project is to develop a low-cost standalone home automation system using the Arduino Mega 2560 as a micro web server. The system allows the user to remotely control and monitor home appliances through Wi-Fi using an Android application without relying on a central computer or external server. This means the entire system can function independently, making it both affordable and user-friendly for everyday use. Despite all these advantages, there are several technical challenges faced during development. First, the system wirelessly range is limited, especially inside concrete buildings where the Wi-Fi signals can only reach about 50 meters and a maximum of 100 meters in open space. Second, the system depends on continuous power supply, which means a power outage could temporarily disable the automatic function. Lastly, the Arduino Mega 2560 has limited processing power and memory, which restricts how many devices and features can be controlled at once. These challenges must be carefully managed to ensure the system remains reliable, efficient, and scalable for real-world applications. Right, now let's look at the key sensors used in this home automation system. Each sensor plays a safety role in making the home smart and responsive. First, we got the PIR sensor or basic infrared sensor. It is designed to detect human motion by sensing changes in infrared radiation from people or nearby objects. When someone moves in or out of the detection area, the sensor sends a higher signal to the Arduino. It is a low-cost, small, and energy-efficient sensor which makes it ideal for home use, such as detecting movement in hallways or rooms. Next is the MQ2 gas sensor. This sensor is used to detect gases like smoke, LPG, methane, butane, and propane. It uses a sensitive material called tin dioxide, which changes its electrical resistance when exposed to these gases. When gas is detected, the resistance drops, and the Arduino reads this signal to trigger an alarm or even shut down electrical devices for safety. The third one is the light-dependent resistor, or we call it LDR. This sensor measures the intensity of light. When light levels drop, the resistance of the LDL increases, signaling the system to automatically turn on the lights. During the daytime, when there's enough light, it switches off the lights automatically, which helps save our energy. Finally, we have the DHT11 sensor. This is a digital temperature and humidity sensor that monitors the surrounding air. It uses a capacitive humidity element and a thermistor to measure both humidity and temperature and then sends the data as a digital signals to the Arduino. It is simple, reliable, and energy efficient, helping the system maintain a comfortable indoor environment. Together, these sensors enable the system to sense motion, detect gases, control lighting, and monitor air conditions, making the home safer, smarter, and more comfortable, and following our IoT of a smart home automation system.
Is the communication method. The communication method in sensors refers to how a sensor sends the collected data like temperature, pressure or motion to another device such as a microcontroller, computer, or cloud system. The first one is Bluetooth. The Bluetooth provides connectivity via the serial I/O pins on the Arduino through which the Android-based mobile application communicates with the microcontroller. Next is Wi-Fi. The Wi-Fi shield provides internet connectivity for the embedded micro web server, which allow internet access and controls from a web application. The next one is Ajax. Ajax is one of the web-based HTTP for our programming language. The next one is the internet. Internet is great source of information and communication in this information age. Communication with this via the internet, also known as Internet of Things, IoT. IoT is a developing technology which allows different things and devices to be controlled via the internet. Now, let's move to the hardware component of the system. Hardware component is the physical parts of the computer or electronic system that works together and perform a system function. First is the Arduino Mega 2560. At the heart of the system is the Arduino Mega 2560 microcontroller, which is also capable of functioning as the micro web server and the interface for all the hardware modules. All communication and controls in this system pass through the microcontroller. The next one is the application contains both a Bluetooth module and a Wi-Fi module, which interfaces with the microcontroller and allows the Android smartphone to communicate with the microcontroller effectively and efficiently. The next one is a relay switch. Relay switch is used to send control signals from the microcontroller to the electronic device used to achieve the switching on and off action. The last one for the hardware component is the power plug. Power plug is to allow connection for power plugs and switching of electrical load within the home. Relay switches are used. The relay switches have capability to carry a maximum load of 10 ampere at 240 volt. This is sufficient to carry any household appliance as the devices do not draw much current. Okay, the next one is for software components. Software components is a set of programs, instructions or data that tell the hardware what to do. For the first thing first, the software component that had been used in this smart home is Android application. The Android application that have built with Google App Inventor and Java. The Android application allows the user to control device and monitor conditions in the home using the Bluetooth connection. Next, we also use the web application. The web application is developed using Adobe Dreamweaver. We use Adobe Dreamweaver as our programming environment because Adobe Dreamweaver has a simple things or simple tasks to give and can perform complex function. The next one is server options mentioned, such as IIS or Apache. The web page will display all the variables being read from the Arduino microcontroller and also be able to perform the functions as the mobile application. The last one is the system also use the Google Speech Recognition engine because Google Speech Recognition can eliminate the need for an external voice recognition module and just use the voice that had been prepared for the system.
Now, let's look at the differences between the three research articles on smartphone systems. The first article, Design of a Home Automation System Using Arduino, focused on an internet-based home automation system using Arduino and Android. The sensors used were temperature, gas, motion, PIR, and light LDR sensors. For communication, it used both Wi-Fi and Bluetooth. The hardware included an Arduino Mega 2560 microcontroller, Wi-Fi shield, relays, and a smartphone. The software used was the Arduino IDE and Android app, and an embedded web server The advantages were low cost, flexibility, and support for both web and mobile control. The limitations were the need for a stable Wi-Fi connection and limited security. The application area was smart home energy control and security monitoring, and the target users were general homeowners and smart home developers. The second article, a smart home system based on sensor technology, focused on a sensor and cloud-based smart home system using Raspberry Pi. The sensors used were light, temperature, motion, humidity, and sound sensors. The communication method combined Bluetooth for local control and Wi-Fi or cloud for remote access. The hardware included a Raspberry Pi microcomputer, Android device, Wi-Fi router, sensors, and a cloud server. The software used was the Raspbian operating system with Python scripts, an Android app, and a cloud platform. The advantages were scalability, real-time monitoring, and cloud-based data logging. The limitations were the limited numbers of sensors supported and dependence on an internet connection. The application area was IoT-based smart home environments monitoring and control, and the target users were IoT researchers, developers, and smart home enthusiasts. The third article, Smart Home Automation System using Bluetooth technology, focus on a Bluetooth-based home automation system for appliance control and sensing. The sensors used were an ultrasonic sensors and a soil moisture sensor. The communication method used was Bluetooth only. The hardware included an Arduino Uno microcontroller, Bluetooth HC06 module, relays, and a smartphone. The software used was the Arduino IDE and a Bluetooth terminal app. The advantages were very low cost, simple setup, and support for plant irrigation and water level control. The limitations were limited Bluetooth range between 10 to 100 meters and no internet access. The application area was home appliance and plant care automation, and the target users were general households, elderly, and handicapped users. We look for the similarities and improvements. For the similarities, all three systems share several key features. Firstly, each is developed using microcontroller-based platforms such as Arduino and Raspberry Pi, which serve as the main controller for automation and communication between devices. Secondly, every system includes an Android mobile application that functions as the primary interface for monitoring sensor data and controlling home appliances, providing users with an accessible and user-friendly experience. Thirdly, all systems utilize Bluetooth communication to establish wireless connectivity between the controller and the user's smartphone, ensuring efficient data transmission without complicated wiring. Lastly, each system integrates various environmental sensors, including temperatures, humidity, motion, and gas sensors to support real-time monitoring and intelligent home automation. In summary, these similarities highlight that all three systems aim to deliver a cost-effective, efficient, and smart home automation solution through the integration of sensors, wireless communication, and mobile control technologies. Improvements. Each study shows notable advancements based on its year of development. In 2015, the system introduced a web-based and Android control interface using the Arduino Mega 2560, which allows users to monitor and control home appliances remotely through both Wi-Fi and Bluetooth. This provided a more flexible and interactive approach compared to earlier single-platform systems. In 2016, the design evolved by incorporating a Raspberry Pi controller, enhancing scalability and processing capability. It also implemented dual communication methods, combining Bluetooth for short-range control and cloud service for long-distance access, enabling real-time data monitoring and automation. Finally, in 2017, further improvements were made through the integration of ultrasonic and soil moisture sensors, which introduced automatic irrigation and water level direction features. These advancements expanded the concept of home automation beyond simple device control to include environmental management. Overall, these improvements demonstrate a continuous progression from basic wireless control toward a more comprehensive, intelligent, and environment-responsive smart home system. For the conclusion, the 2015 article highlighted the development of a low-cost internet-based smart home system using Arduino and Android, allowing users to control and monitor their homes remotely. The 2000 article presented a sensor-integrated and cloud-connected system using Raspberry Pi, focusing on real-time data monitoring and scalability. Meanwhile, the 2017 article introduced a Bluetooth-based smart home system designed to be simple, affordable, and easy to use for everyday applications. Overall, these three studies show the progressive evolution of smart home technology, starting with internet-based system in 2015, moving to cloud and sensor integration in 2016, and finally to Bluetooth-enabled system in 2017. Each study demonstrates improvement in cost, connectivity, and user accessibility, reflecting how smart home designs have become more efficient, practical, and user-friendly over time.